Hello. Hello.
Hello, good evening.
Good evening. Can you hear me?
Evening, ma'am.
Yes,
Okay.
yes. Good evening, sir. How are you
Yes, yes.
doing?
Good, good.
Good evening, ma'am.
Very good evening, sir.
Sanchit ji, are you there?
Yes, sir. I'm here.
Yeah, great, great, great. Sanchit ji, people have come. Actually, there are 36. So we will wait for 2-3 more minutes. And
Yeah,
then
yeah,
we
yeah.
will-
Please take your time and let me know once you want me to start.
Hello. So we are starting now. Before that, allow me to do one thing, everyone. Is my PPT visible?
Yes, I can see your screen.
Right, right. It is visible. So Sanjit ji, and good evening, everyone. Dr. Sudhana is there. Sanjit ji, she is the head of Human Resource Development Center of LPU, and she is the convener of the program. Means she is taking care of all training programs which are held all over pan India, or in fact outside India also. From LPU, she is taking care of that. So Bam Sanchit ji is today's resource person, and
Good evening, Sanchit, sir.
Yes, you can call me Sanchit. I'm alumni of LPU.
he is
Fortunately,
he is the
So
alumni
nice.
of LPU.
That is a
yes.
double privilege for us to have our alumni so well and to be
Yeah.
there as a resource person for faculty from all over India. It is such a big pleasure.
Thank you. So Pratik
And
Agarwal was
that
our.
is also a privilege for me because I want all my alumni to do so well. Let me salute them.
Thank you.
He is 2007-11 batch, right?
Yeah,
Correct.
7-11.
Okay.
Okay.
Right.
So Sanchit ji and Dr. Sunana, we have a customary to rephrase or brief the yesterday's sessions to the participants. So I'm inviting Ms. Navjot Kaur on board to do this today. The second session will be done by Mr. Mani Arora. So Navjot ma'am, are you there?
Yes, sir. Am I audible?
You are audible and you are visible too.
All right, sir.
So let us start because we already become late. So let us start yesterday's briefing about the first program, the first session, which was held by Palvinder ji.
And
So
Ajay sir, just a small request I have for everyone. Since it's the beginning of the session, if majority of us can share the video for some time, it will be nice to just, meet each other. Otherwise, वो one way सा communication लगता है. For some time, if you can share your videos, and we will also take the clicks. Thank
sure,
you
sure.
so much for honoring the request. Vaishali ma'am, Mohit sir, Navjot ma'am, Manoj sir, Srinivasu sir. Thank you so much, everybody. And we have a very engaged audience. You will see them participating in the quiz. Pushpendra sir has joined. Very nice. Pushpendra sir, good evening.
Good evening, ma'am. Good evening.
He's the spirit behind the entire show. Ladies and gentlemen, this entire program has been crafted technically by Pushpendra sir. It has been possible to do this program because of his technical collaboration and taking keen interest in getting this program done.
Thank you so very much, ma'am. This is the initiative which you have taken, and Ajay sir. So that is all your initiative. And then later on, I tried a little with your help. So I am very privileged to be the part of it.
Thank you, sir. And yesterday, your lecture also, it was so hands-on, so meaningful for everyone. And I think that is the lecture that now is going to be summarized also, yesterday's two lectures.
The second lecture will be summarized by Mani Arora. Sir's lecture will be summarized by Mr. Mani Arora. This lecture is of Mr. Parvinder Singh. It was the first lecture. So, Navjot ma'am, the platform is yours now.
Okay, sir. Good evening, everyone. In yesterday's session, that was on parallel computing. Palvinder sir discussed about the concepts, its requirements in the digital industry, and sir discussed about the use and of the parallel computing to increase the performance of the systems by executing the tasks concurrently, and how parallel processing is helping us all to accomplish our daily activities by connecting, controlling all the devices around us through switches, buttons, and the use of IoT as well. Sir also discussed that a few memory models in parallel computing, that how the use of shared memory, which is very much limited, but the use of distributed memory is highly scalable. And he also emphasized and discussed about data parallelism, where some operations are performed on data chunks, and the task parallelism, where multiple objects could be executed concurrently. So overall, sir gave us the need, the use, and enhanced our knowledge by discussing the need of the parallel computing in our daily life as well. So it was a knowledgeable session and definitely enhanced our knowledge. Thank you so much, sir.
Thank you, ma'am. Thank you so much. Very well explained, Ji.
Thank you, ma'am. Navjot ma'am. Now I start the session by just giving a simple introduction, not simple. He is our alumni, so we are proud to give introduction of our alumni. Sanjit sir, we would like to see you there if you are there. Sanjit sir is a solution advisor in SAS. SAS is a company of data science. He is BTech honors in computer science from Lovely Professional University. I wanted to speak that. He has more than 12 years of experience creating this solution based on disturbed architectures that are extremely scalable. He led the team of SAS developers during his 5 years of employment in Pune-based SAS R&D Center. He also provides global pre-sale support, delivery advisory to SMEs, solution development, and content development for the risk, fraud, and compliance division at SAS. Again, I would like to say an alumni of LPU 2007-11 batch. I would like to welcome you on board, sir. Now the platform is yours. Now, I will stop sharing, and it's your turn to do that.
Thank you. Thanks, sir, Ajay sir. And hello, everyone. Good evening. I welcome you all to the third session of high performance computing. So today I will be covering the cloud computing architecture, cloud computing concepts, and how we are dealing all this stuff in using SaaS-based solutions. Sunana ma'am, I can see your hand. If you want to say anything, please go ahead. You are on mute.
No. I didn't want to say anything,
Okay.
sir. Thank you.
Sure. Let me know once you can see my screen. So I will be taking 2 sessions, that is one for today and one for tomorrow. So today I will be covering more from so I have set up the entire these 2 days curriculum in terms of end-to-end flow. With regards to today, I will be covering from architecture perspective. the basic concepts of cloud computing, how SaaS as a platform or how SaaS as an organization is covering those concepts. And tomorrow I will be talking about data governance, model monitoring, model development, and visualization. So it gives a end-to-end holistic view of SaaS platform solutions it develops and how it can provide a better opportunity in different domains. If I talk about banking, if I talk about education, if I talk about pharma, healthcare, sports, anywhere, because everywhere we are now dealing with artificial data. We are dealing with machine learning. We are talking about synthesis, this data synthesis. So it's all about data and high computation. So to make it more intuitive, if you have any question in between the session, please feel free to pose me and I'll try to answer your question. Okay, so what are the typical challenge if we look from the organization perspective, where there is a need for high computable resources or high data manipulation or data computation? Number one is lack of analytical governance, because every small fintech industry or everyone wants to have things done in a very at a very economic value, and they move with open source technologies which are normally dispersed. They need customized support, and the scalability is the main problem. If I talk about big banks like the global banks like HSBC or China Bank, or let's say ANZ or ABN, these banks are having millions of accounts in their portfolio, and to make the decisions for their credit risk portfolio, they need high computation. They need high analytical engine, and with open source technology, they cannot reach to that automation scale. Okay, difficulty in managing portfolio of diverse technology. For different types of operation, like for data management, there is a separate vendor. For model development, there is a separate tool. For visualization, there is a separate tool. If I let's say Power BI or Tableau or Cognos or Visual Analytics. Okay, for source code management, there is a separate tool. So for every single operation in entire software development life cycle or in entire process, we have to deal with multiple suppliers, multiple technologies. And it is becoming very difficult for the organizations to set up a sync between these different organizations or between these different tools. So there should be a single platform or there should be a single holistic platform which can provide all these functionalities as a complete package. Then ever-changing everything. We are continuously noticing or observing that every the evolution with regards to the technology, with regards to the innovation, it is speeding up at a very fast pace, and it is becoming very difficult to evaluate or to cope up with this changing trend. So there should be something where we can rely on the long-term aspects. Then pressure to provide scalable solutions within constrained budgets and rising cloud cost. Nowadays, everyone knows that it is all going through cloud. Everything is on cloud. On premises is like era. Okay, so but cloud costs are rising like exponentially. Okay, and scalability is another challenge that organizations are facing these days, and computational issue, which is the biggest issue in this high high performance and the point where everyone is expecting results in seconds. So to get the result at this much pace, we need to have very high scalable, automated, well governed, well monitored, and computational resources. So if we cover all these issues into a single bracket, then it is a very big overhead for any organization in any domain. So, and SaaS via how this SaaS cloud technology, uh, you know, uh, caters to these issues, caters to these overheads, and seamless or in an integrated way, it brings a seamless experience for an end user that we're gonna see in our next couple of slides. It is not about the sales pitch or nothing. It is just I want to walk you through with the SaaS as a platform, SaaS as a technology, and how you guys can learn about this technology and can get better with this cloud technology. Okay, so enable data driven decisions at a scale and gain real value from your analytics investment. Okay. So starting from data management until monitoring, it is holistic, the end-to-end process. And in any bank, in any fintech institute, in any healthcare, in any education system, managing a data is a biggest challenge. And once you have the data management tool in place, then how are you using this data to get the proper insights? How are you using those data points to generate the proper analytical trend? That is again challenge. And these two divisions are not integrated, are not seamlessly talking to each other. Okay. So, and this is the demand of any digital business, which expects that there should be a comprehensive data and AI platform which manages its data in a well-governed manner. It should be able to build, optimize, and validate the models to get the real information. And finally, there should be something on the decisioning side to develop the business policies to automate or to monitor and to reiterate the cycle. So all these steps should be seamless and integrated. Now, SaaS via connects all the aspects of data and artificial intelligence model development lifecycle, which helps to turn your critical questions into a trusted decision. It is end-to-end, means covering all the aspects, cloud agnostic, open source integrated, data scientist skill agnostic, and post-performance leader. Now, this is the holistic view where all the open source developers, all the SaaS developers with let's say the Java, any technology, who the developers who knows any language, any programming language, can bring their code, can write their code using SaaS platform. It can consume any data formats, like if I talk about traditional, our RDBS databases like Teradata, Oracle, our file system based like Hadoop, MongoDB, SAP HANA, our file systems like CSVs, Excel file, any file format can be ingested in SaaS via solution to generate the trends or to get the analytical insights. We have this provides the visual analytics tool, which is the dashboards. These everything is low code, no code platform, and this entire platform decreases the dependency on the outer world. Okay, that's the another benefit. Now, If I talk about the seamless experience, so in the managing data section, we have data for analytics and decisioning, which is done by accelerated data storytelling and increased speed to a volume. If I talk about the model development, thread automation, intelligence through a data, parallel processing, artificial-based intelligence, and machine learning like gradient boosting, XG Forest, all those modeling algorithms are available out of the box in a solution, and you can directly use all these models with a from a solution from a solution itself. And you guys all know now, even the upcoming students in the engineering streams, or even in the grad streams, they are rushing towards this AI machine learning streams. They are looking forward, or they want to learn more about this machine learning, artificial intelligence, and they want to become data scientists, right? So this is the high time for 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 the universities. This is the high time for the colleges to include a separate curriculum where they can leverage these tools or these programming languages which are available in the market, and is being demand by the different organizations, right? So, and this is the main, I would say, intention of bringing all these technologies, bringing this SaaS via architecture, bringing this SaaS models in this session, so that you get aware, so that there is some interest from the organization, so that they can start including such type of curriculum in the practice. Now we'll talk about the architecture. So there are the basically three major components of VIA architecture. Number one is engine, which is the important piece. As we all know, it's like an engine control system, which connects and they monitor all the aspects of the platform, making sure each component does its assigned job, and a whole platform functions without any failure. So when I'm saying whole platform functions without failure, means it has proper data recovery, proper grid orchestration, proper resource allocation on failure. Then supporting part. When I'm saying supporting part, means the vital components that are gateways to analytical functions and the features. Now, let's drill down into the three major components, which are like our engine, control system, and the supporting parts. Okay. So, and then this in the engine, we have our analytical engine. On cloud, we call this is being named as a cloud analytical services, which is called as in short, it is called as the CAS. So this CAS is 30 times powerful than the normal computation resource. In terms of the infrastructure servers, it has its own compute server. It has own the workload servers. It has on the worker nodes. It has on like everything. It comes as a complete package. Microservice entire platform is microservice driven. Entire different modules are, or different features are module based, and all and every entire architecture is Kubernetes based. Okay. And these microservices are directly integrated or directly coming exposed to the customers, exposed to the outer worlds through the web apps, where where for every tool there is a web service, there is a web application. You don't need to install or These as a desktop application, everything is on cloud and web driven. Supporting services, these are the operational parts to enable the communication of the platform. Okay, so now we will focus on the two major components and the concepts and their values. Number one is CAS, which I said this is the main analytical engine, or this is the engine of entire via architecture. This is distributed in-memory computing engine. When I'm saying in-memory, so there are two types of computation. One is everything is getting computed using the physical hard disk or the physical memory that we have available in the device, and this is something on top of which is in memory. Like there is a dedicated space, and we call it as a memory, and data get lifted from the physical disk, gets loaded into the memory, and it computes with higher computation power, and it gives me the results in seconds. So if I talk about, let's say, 12 million records or 5 million records, or even in billions, the computation the computation power goes around 5 seconds, or let's say 10 seconds, right? Then microservices. Microservices, if I talk up from the definition perspective, it is self-contained, lightweight platform component. It can directly deploy it into a small containers as like based on the Kubernetes architecture. Every functionality, every feature can be triggered or can be created as a microservices, and these microservices are gets derived using the REST API, which are being written in the Java, and these REST APIs can be invoked, can be called through different platforms like Postman. You can call these APIs from any other language by preparing their JSON files, by preparing their headers, and completing the signature, and finally you get your work done. Now, this is the architecture, the basics of the architecture, and the complex is way behind, and or not way behind, way beyond. So the dark blue section, which is the engine, as I said, the CAS and the compute server. CAS is all cloud, where everything happens, or all the computation happens in memory. And SAS compute server, this is process SAS codes and procedures in the form of the jobs. And the supporting parts, which are like the third-party applications like Postgres, RabbitMQ, Consul, these we call it as a SaaS commodities, and these services allows communication between different components and more. And if I talk about the controller, the control system, the third component of VIA architecture, which is microservices and the web apps. And well, as I mentioned or covered in my previous slide, that microservices are standalone operational tasks, and every single functionality can be created as a microservices. If you see here, let me get the pointer. If you see here, we have the microservices for monitoring, which goes about for the server monitoring, the job scheduling, the configuration, the cache management, the audit trail, the file transfer, the authorization, job flow. You can write series of the steps of the SaaS of the program in terms of a job. For the mailer services, it comes as a microservices. So as I said, all the basic functionalities, all the major components comes as a microservices. And These microservices are hosted in the containers with the Kubernetes based architecture. So if any services goes down, it brings up a new container, new port, and services automatically gets up and resume the operations. So that's how it scales, and it prevents the disasters and the overall failure of a platform. Along in the CAS, in the engine part, we have the CAS controllers and the worker nodes. So based on the computation required, based on the need, these workers these worker nodes can be extended or can be removed. And this CAS controller, it distributes the load between these worker nodes. Data gets evenly distributed in the worker node. So it supports serial processing, it supports parallel processing, it supports in database processing. When I'm saying in database means, let's say if you have your database or your entire transactional information is stored in third-party software like Teradata, Oracle, Hadoop, SAP HANA, you name any XYZ, or let's say BigQuery. Okay, so and the computation, the architecture or the resource, entire resource is being used as a wire. So if I have to read data from the database, then there are two options. Number one, data will outflow from this database like Teradata, Oracle, will process in via, and then will write back to that particular database. And in this process, there is a lot of IO operation. Let's say if I have to process 12 million rows, then 12 million rows from a table will come to SaaS ecosystem, will process, and then will go back to the Teradata or let's say MySQL or Postgres. You name any database. But what SaaS to handle this overhead, to decrease or minimize the IO operations, to minimize the data operation between for every read and the write request, it comes up with the in database processing, where it converts the SaaS, it converts your SQL queries automatically into the native language of a connected database. So the developer who is writing a code in SaaS platform will automatically convert into which is the code which is native for, let's say, Oracle or Teradata or Postgres or SAP HANA or Hadoop or Google BigQuery. It can be anything. And the code will directly execute on that particular table in that particular database, and will read from that table itself, will write in that table. So there is no data movement between the source, between the software and the database. And this avoids the data movement and overall increases the performance and decreases the computation time, right? So that's how this entire powerful architecture is. And this is in practice, I would say, since last 30 to 35 years. Okay, the big organizations, the big banks, everyone is using this architecture, and they are native with this. So if students are aware about all these types of architecture, if students are aware about this programming language, this can help this can help to secure or to get the good starting in their initial career. Now I will talk about this CAS, distributed and in-memory computing. So as I said, here we have the disk the physical disk, which is available on a device, and to increase the computation power, to decrease the performance time, data gets lifted into the memory, which is directly associated with the disk on a same device, and it increases and it computes everything inside the memory. So when I'm saying distributed in-memory computing engine, means distributed computing supports speed and volume. When processing big data, cache excels by running workloads in parallel to increase not only processing speed, but also resiliency in case of failure. Now, in-memory data retention through a series of analytical action, which is less data movement between disk and RAM, memory management to optimize memory space, isolate sessions, but share memory among different user groups. So if, let's say, from a disk, I have lifted a table into a memory, and this table will be available for all the users who are using this resource. So no need for other 10 or 20 or 50 users who are using the same environment to lift the table into the memory. Data is readily available for other users as well. Okay, so just like sharing the resources, sharing the time, and reducing the performance, or reducing the computation time. Now, this is where cache controller distributes workload across the cache worker. As I said in my previous slide, where depending on the load, depending on the performance required, depending on the computation or the data available, these worker nodes can be increased or decreased, and it is being managed by the cache controller. Okay, so these worker nodes supports parallel processing with multiple sessions, data redundancies, and fault tolerance. Okay, so if, let's say, one worker node gets down, another worker node will automatically gets up and start and resume the operations. You might have heard about this AWS and I would say GCP and S3. Okay, so all these are like the resources that much you use, you have to pay for that level of the usage. And these similarly, this type of structure is now being used or adopted by different cloud-based architectures organization. Microservices. So what I'm doing is, in my previous slides, I have covered in terms of the high level. Now I'm going one level down, where these all components of the VIA architecture are being explained in detail. So as I said, microservices is the small object, or the small object, or as a separate, as a independent component, and for every for every feature or for every functionality, one microservices can be created, and these are backed by the REST APIs. So microservices are obviously light, self-contained, and the lightweight piece of software, and this can be deployed in any container over the runtime in Kubernetes-based architecture, because today is the trend of Kubernetes. Okay. Then these are the stateless, which makes it less I would say space consuming. Okay, and perfect for and making them a perfect match for the containerization. Now, The benefit of microservices is agility, as failure of microservices is isolated from the rest, because these all microservices are independent. They all work in silo. Okay. So if let's say my cache management or my backup services, my backups microservices get failed, then all other microservices will remain active. And one team can fix the backup microservice and can bring the service back up and running. Similarly, the audit, if let's say some disaster happened with the audit microservice, so fix that particular container, fix that particular microservices, and bring that service back up and running. So it does not affect my authorization. It does not affect my job flow services. So entire solution will remain up and running. Only that particular piece will get affected. Okay. And this containerization, this independent installation of all these lightweight services make it elasticity. Like I can remove, add any microservice as required. Okay, which again reduces my cloud cost. It reduces my the software requirement. It reduces my computation resources requirement, right? So that's what this entire distributed architecture, the independent installation of the services, make it overall cloud installation robust and economic to the institute. Okay. Okay. So before I move further, I'll take a pause for a second and let ask from the audience if they are with me, and is there any question? Okay. Ajayji, we have the quiz, so you will run the quiz session in between, or
I'm running one quiz. If you allow, I will run one quiz.
Please.
Okay, so in chat box, I will be giving you the link for the quiz. In chat box, I'm giving you the link for the first quiz. So just wait. This is the link. It is coming on chat. So this is my first question. It was given to you. Kindly do the question.
Yes. Please answer the questions, and if you have any question, please ask, so that it doesn't seem like I'm the only one who is speaking in a session. Let's make it more interact. The more questions you will ask, the more interest I also get to interact with you guys. Please.
The audience is participative.
Sir? Hello?
Yeah, Manoj, I can hear you. Yes.
Sir, can you briefly tell us about SaaS? Actually, those who are not from computer science background, they may not be familiar with SaaS. Can you
Okay,
briefly?
sure. So SAS stands for Statistical Analytics System. It is a company which provides or which does data analytics. They are the pioneer in data analytics. It's a US based company, and I'm part of this organization. So for this is mainly okay. So the main resource which is SAS does is data analytics, and it does data analytics, data management, data visualization, model development. So if you see from the different domains like healthcare, like education, like banks. So I'll take example of bank and where does it help. So in a bank, someone goes for in a bank to apply for a loan. It can be a personal loan, it can be auto loan, or it can be mortgage, anything. Okay, so whether you will be allowed to sanction a loan or you get your CIBIL score. In India, we have the CIBIL score, right? So how does you get your CIBIL score? How does bankers realize or detail out your performance, right? Or how does they get what will be your EMI amount? So there to evaluate everything, there is a backend process which happens in the IT side of a bank, right? So they develop models, they do predictions, they do early warning signals, they do stress testing. The credit risk department does that. We need to sanction or we need to give loans to the people so that bank earns. Similarly, there is a separate division which is responsible to maintaining a sufficient amount of capital in their bank, so that if, let's say, people default, then the customers who have their deposits, how bank will give back those deposits on their maturity. So this is entire process which is being managed through models, through data preparation, through visualization. So all these things are handled with using a SaaS solution. There are many tools in a market, right? You can write everything through open source language. So in short, this is a programming language where you can use this language for data analytics. You can use this programming language for predictions based on the behavior which is being observed in the past. You can visualize like simple people generate pie chart, people generate bar charts in Excel. Same way, you can process high volume of data and can prepare such type of visualization in SAS as well.
Thank you,
So
Manoj,
that's great.
sir. That's what actually asked. Sir, I have one more little question. Sir. Like SaaS is one of the dedicated analytics platform. So
yeah.
what is the source of data which is being available with SaaS? Like
Okay.
for all three, those who are doing free data analytics, they are accessing like from Kaggle, if I'm not
Yes.
wrong.
Yes, yes,
That's
yes.
what I'm asking. What are the resources or source of data which is being available with
Okay, okay. So there are two things. Number one, the data, and the number two, the software. Okay. So for the data, because SaaS does not provide data. SaaS is not a data provider company. Okay. So for data, you have to go to external sites like Kaggle, as you mentioned. You can synthesize your data. You can use SAS programming language to produce synthetic data. Okay, you can use Excel to synthesize data. Okay, once you have data, then you can use university editions of SAS softwares to start the basic programming language. Okay, if someone has exposure to any programming language like C, C++, or any basic language, they can write a SAS program quite easily. This entire language is case insensitive. Entire language is object oriented, and this entire language is procedural. Okay, so you can get the university editions from the official SAS websites and can start learning or can start using the power of prediction. But data you have to get from the external sites like Kaggle, or there are a lot of resources on GitLab or GitHub as well, where you name anything. Like, let's say if you write uh, credit card data, you will get plenty of resources on Kaggle where you will get those mask data with all the attributes. You write state. Nowadays everyone's talking about climate risk, right? Banks have also considered the climate risk factor in their decision process of loan lending. So you write on Kaggle climate risk data, you will get everything like precipitation, temperature of last 10 years, of last 5 years. A lot of data is available on Kaggle. Yeah. Manoj, does this answer your question?
Yes, sir. Thank you.
Excuse me, sir.
Okay.
Good evening, sir.
Yes,
Sir,
Manoj.
we were talking about microservices, right? So there's a
Yes.
concept of monolithic architecture. Like,
Yes.
is somewhere these are related or different?
Yes, it is. It is actually monolithic architecture. It is.
It
So
means,
when I'm saying,
right, sir.
yeah, please.
No, I was a little curious around. It's written there, no, self-contained, lightweight piece of software.
Yes.
So that's why is it like it's directly somehow in close communication to making changes to the like entire communication is at the same privileged level or somehow. So is it? So my curiosity is like, is there any difference, microservices and the monolithic architecture, or these are
Actually,
same?
these are same. So microservices is the container based. So you can deploy, you can create a tiny and a big microservices depending on your requirement. So if, let's say, I talk about uh, the functionality of mailing, okay, that will require authorization, that will require the mail, the SMTP, all those protocols. So you can combine these two functionalities into a one, which can be a bigger microservices, or you can create the atomic level microservices, right? That can be used with other components as well. So it depends on the technical architects who are designing the entire architecture platform. How do they want to club, or how do they want to distribute these services into a several components, right?
Okay, right.
So
So it's like a
the
container that is running in as a monolithic.
as a yes, so this container is okay. take container as the one PC.
True,
Okay.
true. Understand. Right.
One container is one PC. Okay.
Right.
And one microservice is running on that particular container. It's
Oh,
this.
understood. Right, sir.
Okay?
Got. Right, sir.
That's why you can see here, all these blocks are independent. They are talking to each other, but they are not dependent on each other. Like, that's why I said independent, self-contained, lightweight piece of software. Okay.
Got it. Right, sir.
Independent.
Right, sir. Thank you so much.
Okay. You can call me Sanchit because I'm not that like I would say big in age.
Sir, definitely we earn respect with the knowledge as well, sir. Age is, it hardly, hardly defines whether to or not to add, sir.
Okay,
So
thank you.
definitely. Thank you so much.
No worries. Okay. Okay, let's move further. Now, future of being cloud native. Containerization, it shortens the time to deploy any microservice, any application, easy day-to-day IT operations, and DevOps methodology. You might have seen the interest, or you might have seen these days that everyone is talking about data scientists, everyone is talking about DevOps, Kubernetes, pipeline, Azure pipelines, DevOps pipeline. So this entire era is of cloud native technologies. And if we as a teachers, we as a faculties are aware or are educated about these cloud native technologies, then we can do innovative stuff with the students. And I can guarantee that students will take interest in doing POCs, in developing some piece, some like a fun activity around playing with with uh, with with these all new technologies of this era. Okay, so Navjotji, now I will you asked about the containers and the Kubernetes, so that's my topic that I'm gonna cover these now. So
Right,
from the, as I said, this entire architecture is Kubernetes based. So now let's talk about Kubernetes and the containers. So what are the containers? Containers is, okay, container is again, when you heard containers, like a cargo container, okay, the big 20 feet, 40 feet container, okay. These containers allow for the isolation of applications with their entire runtime environment, making it fast and easy to move applications between the users or the environments. Like, environments means different dev, test, and prod, while retaining full functionalities. Okay. Kubernetes is a container-based orchestration technology. It provides a declarative method to manage the clusters of containers. So there will be multiple containers, and group of containers is called as the clusters. And Kubernetes manage or defines the method to manage these clusters, okay, in a efficient way. Okay, what is the benefit of container? Number one, this is lightweight. These are isolated, self-sufficient, not depending on the other containers. As I said, consider container as a virtual PC, or as a one physical device, because they have their own operating system, or they can share the operating system as well, right? Reducing the overhead, reducing the OS overhead, and lowering the startup time. Portable. One container is abstracted away from the OS, so it can be used for development if needed. Up, bringing down, bringing up, playing with with these containers is quite easy. And in case of failure, in case of disasters, we can bring the other containers, other of our singular microservices quite easy. Okay. If you see for the disposal or for the immutable, or in case of failure or obsolescence, a container can be deleted or replaced quite easily. Softwares can always be functional and up to a date within a seconds or within a fraction of seconds, I will say. Okay. Now, container architecture. So again, container, as I captured here, multiple containers. They share the operating system. They share the infrastructure. Different apps or single app can be installed, or single microservices or app can be installed in one container. The subsequent dependencies of that particular microservice will also get installed in that particular container, so that container becomes independent, isolated, and in silo. Okay. From the software point of view, a container wraps around and provides isolation for programs. These dependencies needed for the program are included and will be initiated when a container starts. So once a container gets started, the underlying dependency, the OS sharing, the OS part which is being shared, all the microservices, everything gets started, and it makes it available for the web apps, for the other functionalities of entire software, make it available. Okay. Note that that container is different than a microservices or a virtual machine. Now, how containers and SaaS, so how SaaS uses this containerized architecture. Okay. So if you remember, we had the CAS controller and we had the worker nodes which are distributed or get controlled by the controller node. Okay. Now, individual CAS worker is a typical one container. Okay. So here, these CAS worker 1, CAS worker 2, these all worker nodes are wrapped around containers, and even the CAS controller is wrapped in a container. So that's why when I said, if let's say one worker node gets down, automatically the another worker node will get spin up and will start performing, or will start resuming the business. Okay. So as I said here, it is being written in the slide as well. The CAS components are wrapped in containers that are fully isolated from one another. Okay. This process allows predictability in the CAS behavior, as well as the ability to kill any failed CAS component or create a new one with no downtime. So as I said, it brings up in fraction of seconds. So there is no downtime. It will be a seamless experience for the user, like nothing happened, and like everything goes as it is, right? Okay. So Kubernetes are defined as the open source orchestration system for automating the management, placement, scaling, and routing the containers. Okay. Princey Sharma, can you please mute yourself?
लंदन में आपको आपको फ्री हेल्थकेयर मिलता है, स्लोवाकिया में आपको फ्री ट्रांसपोर्ट मिलता है, साउथ अफ्रीका और यूरोप में आपको फ्री पानी मिलता है, बिजली भी मिलती है, न जाने क्या क्या। क्यों कि अगर हम
Yeah, sorry. Thank you. Yes. So I was explaining Kubernetes, which is open source orchestration system, and which is being used for automating the management, placement, and scaling and routing of containers. So it manages the end-to-end process of cluster, it manages the deployment and it manages the all the containers which are being deployed in that platform. So it have planet scale, which offers secure reliability and unlimited scalability with high performance. Unlimited growth, it allow because it is quite flexible and it grows with you to deliver your applications consistently regardless of complexity. This is cloud agnostic, and to any infrastructure, it gives you the freedom to leverage your infrastructure of your choice. You can use any cloud like Azure, you can use AWS, you can use GCP or private cloud, anything. This is irrespective of which cloud you are using, which OS you are using. It can execute it anywhere and can move these and can allow to move the microservices from one server to another in fractions of seconds and a seamless way with seamless experience. Okay. Now, what are the benefits of Kubernetes? In brief, two cornerstones of Kubernetes benefits are immutability and declarative deployment. When I'm saying immutability means if there are any updates with regards to the Kubernetes, the version or the OS that on which this entire architecture is being deployed, a net new container will be created. This eliminates the need for the maintenance and makes it easier for the rollback. So automatically a new container will be created following the new updates, and whatever work or whatever data or whatever services being deployed on the existing container will automatically get shifted to a newly generated container. So just like lift and shift mechanism from one container to another. Okay. Declarative deployment is, which is because Kubernetes is used to manage the deployment and the performance of resources. So eventually it helps while reducing the administrative efforts of IT users, because it is quite easy to manage. It has less to do with the resource failures, with the automation, with the scalability, to keep an eye on the hardware performance, to keep an eye on the servers which are being up and running. So overall, it reduces the administrative task of the IT users managing the entire environment. So it also says or covers the same, like Kubernetes help IT professional the burden of configuring, deploying, and managing, plus monitoring containerized apps. Okay, so it allows or it gives the seamless experience it for every persona in the organization, like the IT deployment guys, the guy who is using the resource, the persona or the team who is from data management, the team who is from visualization, the team who is from the development side. All the different personas are getting seamless experience throughout the architecture. And this is not related to SaaS. This is the all these Kubernetes microservices are openly available, and these are the cloud native technologies, and these are available for anyone who is learning cloud, okay, or learning cloud technologies. Okay, so this is with Kubernetes, how Kubernetes in the orchestration environment of SaaS via, as in I've used a similar deck in a couple of slides before, where I presented the container, how this container is being used, and how the basic architecture component, which is the control, the engine, the control, and the supporting parts. And now how the Kubernetes, the Kubernetes component is available in that particular component. Okay. So here you can see the data fabric, like it can read data from different formats. It can be the native SAS data files. It can be a flat files. It can be any database like RDBMS, Teradata, Oracle, Hadoop, SAP HANA, anything. SAS compute server, which is for the on-device computation, and the cache controller and the worker nodes are maintaining everything. So that's from the data architecture side. Okay, so what does efficiency, agility, and integrity looks like? Okay, so in the traditional world, it's not about SaaS via or where without cloud architecture or without cloud-based, cloud-native technology deployment. Okay, user experience is disjointed and siloed. Okay, but with the cloud-native technology, this can be integrated and seamless, because all the personas come together and they manage or they manage the single platform. Initiation and planning in terms of from the IT administration side, it is sequential and siloed if it is traditional, but with cloud native, this is collaborative and quite iterative. Okay, model development or any deployment or any development, we have to write the codes. Okay, the manual, we have to write the manual code, but the cloud native technologies, or particularly SaaS via, there are the standard templates. It is low code, no code platforms. You just drag and drop the components, use it as it is, and if required, you can customize these components. Okay, deployment. Without having cloud-based architecture, it takes months to deploy stuff into the production. But if we have these DevOps pipeline or these Azure pipelines-based architecture, then these months can be reduced to days. And monitoring and governance automatically, because if like as we have seen in the previous slide, where Kubernetes reduces the administrative efforts or administration tasks for the IT people in terms of the governance and monitoring. So this is what captured in this slide as well. Okay, so I've taken the example of tier 1 banking, like a big bank, okay, with SaaS via. So, and it can be any machine learning platform. So online application which has like 50 screens in the past, and with this orchestration, that reduces to 5. Okay, application to account access means the time where application came into a bank and reduces or it gets screened and decision made and converted into account same day. Okay, launch of new feature, time to yes, marketing campaign. Campaigning is one of the biggest tasks or one of the hectic process in any institute. Okay, they have to spend a lot of resources, a lot of in terms of money as well for running the campaign of a particular I would say festival or any topic, right? So it can reduce it can be reduced, the marketing campaigning cost can be reduced like significantly. Okay, retail banking customers overall operationalizing and algorithms and the models. Okay, so this is what I wanted to cover, and I have kept remaining 5 minutes for the Q&A session and the quiz. So I will stop my screen share here, and Ajayji, you can post the another question on the Teams on the chat, and later we will circulate the overall quiz. Yeah, Ajayji. Hello. Hello, Ajayji. Okay, meanwhile, probably he's on mute. So you guys have any question? So how about the session? Did you guys like or the session, the content? I try to keep it uh, short and less, simple, like quite simple, so that you can understand it well.
There was a technical issue. So we are going to have another question for you. And remember, when you are answering the questions, take care of the time you are taking to answer the question. As the early you answer the answer, and your answer should be correct, the more near you are getting to earn a reward. So top 3 people who are answering the questions early are going to get a reward. So I'm putting the question on chat. Hello. So the chat is there, right? In the chat, the question is there. Let's start doing it.
Uh, Even I try to keep the questions simple so that I can make you familiar with the topic and accordingly you can answer the questions. Ajay ji, shall we close the session?
Sanjit ji, are you there? I'm here now.
Yes. Yes. I was asking, are we
Okay.
done?
Mm, yeah, if you are done, we are done. Thank you very much. You spare your time. I
Thank you,
can
sir.
understand you were having a customer interaction and you left your customer interaction and came, you fulfilled your commitment. That's a great gesture, and we will see you in the another session also. So,
Yes,
ladies
see
and
you tomorrow then. Yeah.
yeah, we will see you tomorrow.
And
Till that
we'll
time,
keep the
yeah,
same track. So
uh,
today I have covered the architecture front. Tomorrow I'll
right.
cover it from the data and from the modeling perspective and from the visualization perspective. So you will see the end-to-end flow, how entire session is going.
Now, what I want to say one thing is, it's a request from all of you that please put your content, the PPT on the group so that people can take advantage of it.
Sure.
Right, sir? Thank you very
Okay.
much.
Thank you.
And see you
Thank you,
tomorrow.
sir. Thank you, ma'am.
Thank you very much. And so
Thank you,
nice
ma'am.
to have our LPU alumni sharing inputs with all the participants. Really very meaningful for us. We will also mention it to our Chancellor Sir and Pro Chancellor Ma'am that such is the height that our alumni have reached. So proud of you.
Thank you. Thank you. Thank you.
Thank you.
Bye-bye, guys.
Bye. Have a great day.
Thank you.
Ajay sir, will you be giving a 5 minutes gap before the next session?
Can take 5 minutes gap. They can have a cup of coffee and come back.
Okay. Who will be making it?
Uh, Themselves only.
Okay. Thank you. Gagan sir has joined. Sir.
Just 2 more minutes, guys. uh, the resource person is supposed to join from Australia. Maybe he's traveling somewhere. Till the time, if you have any queries, kindly let me know. I'm going to solve your queries in this case. If someone wants to say something, or you want to share your feedbacks, because he is getting late because he is having some issues. He will be joining.
Meanwhile, can we have, as you rightly said, Ajay sir, some feedback from the participants that so far how are the sessions moving?
Yeah, ma'am. That's what I'm asking them.
No,
They
very
can.
right asking. So, and if anybody would just like to give us an idea about how the things are moving and what are you looking forward to in the upcoming sessions? Or sir, maybe they've had long stretched sessions, so they can take a few minutes to relax also. As sir is joining, Manpreet has already confirmed that sir is joining soon.
Right, ma'am. Yeah. In fact, if somebody wants to speak, we can speak. We can gossip also. But the topic will be the sessions only. We keep talking with the LPU faculty. Any other faculty if you want to talk? People from Maharashtra can raise your hands. Borkar Saab, he's in Nagpur. He's from Nagpur, I think so. Dilip Borkar, are you here? How many of you marked your attendance today? Raise your hands. How many of you marked your attendance? No, FDP session is not over, sir. FDP session is not over. It is still going on. The resource person is joining soon. He will be joining from Australia. So maybe some technical glitch. So he will be coming in a while.
Sorry for the little bit of a delay, but this is Gagan Sharma from Melbourne. How are you folks doing?
Very good evening,
Gagan,
sir.
Good
good evening,
evening.
Gagan, sir.
Well, it's for me, it's the middle of the night, but it's a pleasure to join. Hello, everyone. This is Gagan Sharma.
So,
Hi, sir. And such a pleasure to have you on board. Thank you for making it.
No problem.
Gagan, sir, before you start your session, I would like to introduce you to the audience. We have Mr. Gagan Sharma, is founder, CEO, and backbone of a company called Proxmed in Australia. And he is head of informatics, Melbourne Brains Center, Royal Melbourne Hospital, Australia also. Now he's created a company which is next generation informatics platform that offers a range of services to support clinical research. And he provides clinical trial offsites, data handling, data organization, processing, visualizing, and over two decades of experience he is carrying. And he is expert in leading and creating solutions for neuroscience research, including large-scale clinical trials. He knows a lot of languages, as you know. Now comes to his I would like to talk about this, Gagan sir. He and his team expanded Proxmed into new verticals, and these verticals basically, particularly his subject matter expertise lies in acute stroke. And this expansion was backed by top industry leaders, clinicals and engineers trained in field. Like he has a good connection with IIT Delhi, Peridolia, Zenova, and other big companies. And one thing is that in IIT Delhi's exoskeleton device heads for international footprints to Australia, his company is doing the clinical trials. And not only this, but serving the community, empowering women in technology industry, promoting gender equality through Girls in Tech, a global non-profit organization, and one more organization is the Shequel Foundation. It is focusing on gender equality. He's making sure that equal opportunity is given to everyone in this field. Now, one more thing I want to talk, that Gagan sir is associated with LPU in this area. I would like to, this was Mark Parsons Scholarship for LPU students, and we had a hackathon for LPU students 1 year back, I think so. And in that hackathon, the students not only got prize, they got placements in his company also. So a great person to work with, a lot of things to learn from him, and a very old associate of lovely Profession University. Gagan sir, I welcome you aboard, but before that, I would like Dr. Sunana to speak a few words about you.
Thank you, Ajay sir. I will speak few words only, but thank you for giving me the opportunity. First of all, such a pleasure to have you with us, Gagan sir. Thank you for making it, for Lovely Professional University, for All India Council of Technical Education, and for the 80 plus academics who are here with us to enroll in this course on high performance computing. Thank you very much. My dear friends, Gagan sir is a friend, philosopher, and guide to me. Whether the matter is personal or professional, he's the go to person for me. And his advice in professional areas is always very well researched and totally something that you would look forward to. With this perspective, we had invited him to the AICT sponsored FDP, and he has very kindly consented and been with us. Thank you very much. He has 2 sessions. One he will be taking today, and another on the last day, in which he has kindly involved his team also in the session. As Ajay sir mentioned to you, we have an MOU with Proxmed, wherein 5 of our students are associated with Proxmed, working internationally, getting great exposure. And 2 of the students have completed their graduation and working at a good rank with Proxmed. Today, we also have Miss Manpreet Kawatra accompanying Gagan sir. Welcome, Manpreet. And uh, I will not take too much of your time, but would just like to say that when the learning comes from a person who has done it hands on, I think the learning is totally different. Gagan sir has his roots with Lovely Professional University and with the city of Jalandhar. He started his career from here, and I believe our success in life is not where we have reached, but from where we have started. So it's always a proud moment for LPU to reminisce the beginnings of careers at LPU, of careers like Gagan Sir's. And we're very proud to have your association. Over to you. I can speak on and on, but I think it's not good to take more of your time. Thank you very much. Over to you, Gagan Sir. Thank you.
Pleasure. That's a very kind introduction. And also, first of all, hello to all of you. It's a pleasure to see all of you at such a late hour in India. I know it's a very late in Melbourne here, but And apology for, I may be a little bit, couple of minutes late, so apology in advance. Yes, I worked at the lovely Professor University for a couple of years, but it was of a great fun, but also it was full of a lot of learning. Let's get started so that we don't waste time and can hit. Okay, here we go. All right, I'm about to share, so you folks have to tell me if you're able to see my presentation slides. Give me just a sec. Okay, are you folks are able to see my slides, or maybe, let me see. Give me a sec.
And it's visible.
I want to share the proper
Yeah,
screen. Give me a sec. This is desktop 2, but I want only the window, which is this. Are we good? May I ask, what are you seeing? Are you seeing the notes, or you're seeing the full screen?
it's the full screen MPI programming.
The full screen.
All right.
You see the full screen.
Thank you, Dr. Sunena Kurana. Thank you for confirming. Okay. So, folks, again, I will be telling you a little bit about the programming, but I will be focusing today on my presentation on some of the example my team is working on, and I hope that will make sense. So I have not too many disclosures. But before I start, I would like to tell you that I'm still a student. It's not that I'm going to tell you and I'm expert in everything. I know a little bit, right? And until the age of almost 30, I wasn't sure what I was doing. I started my career as a master in computer science application. I know that many of you, and I assume I'm seeing that most of my audience, I can see a doctor in front of them, but I'm not a PhD yet. However, I will explain why and how much work I have done in this domain. So you may be able to appreciate a little bit. But as I said, that until the age of 30, I wasn't sure what I was doing, including when I had 4 years of my work in France. So I started my career, give me a sec. Sorry. Yeah. I started my career, my first job was in France. And I worked at the institute where I got a full scholarship, and it's called the ENST, École Nationale Supérieure de Télécommunications. And from there, my second job was at the lovely Professional University with my colleague, Dr. Huja. And again, as Dr. Huja said, we can talk, but I will focus on the topic which is given to me for today's presentation. But one thing I figured out through this journey is that once you find your moolah, when you know what you're doing, you feel limitless. And that's the fun of the work. Monday is not a Monday. Monday is like a day when you really want to go to work and deliver. And for us, the day of the week doesn't matter. What matters the most is the challenge we have in our hand, and we want to overcome that challenge just for the purpose of why we are spending our time and energies to solve some problems. And now this slide may tell you I'm a little bit old also, right? I started my career in 2002 GNDU, 2005 I finished at the ENST. Then in between I worked at the LB Professional University. But these are my educational qualification. And in 2016, I also did my Bachelor of Administration in Project Management in Australia. Now, you don't need to focus too much in, but why I have left this line, MPI is a new concept or old concept. By the end of this presentation, we may come to some conclusion. Now you must be, I think, Mr. Sharma, who shares the same surname as mine, Ajay Sharma, has given a very kind introduction along with Dr. Huja. But over the years, the image processing in medical domain is something I love to work on. And the question comes, why, right? Because the solutions we are creating for our clinicians to focus on the patients. And with our tools, the clinicians work with these tools to take a decision which is always helpful to deliver the best possible outcome for our patients, right? And when I see these patients, I see them as our family members. God forbid, as you all know, that I work in acute stroke domain. Stroke is a very devastating disease, very devastating disease. But if you can do something which could be helpful to the patient, I think that really fulfills your life, and you enjoy what you do. And that's what really makes me very happy when I work in this domain. And when I say I work in stroke domain, I work in a hyper acute stroke domain. And that's where my whole team focuses. At Proxmed, we run many verticals. I don't want to go too much into that. But one of the picture you were seeing, there was a young student called Aditya Chaturvedi. He was in the picture, which I think in my introduction was being shared. He's one of my leading AI AML engineer who is creating many solutions for us, but I will explain that solution in context of the MPI programming also. Now, over the years, I have been lucky enough. I've worked in the many big clinical trials. And when I say clinical trials, don't think it as any XYZ clinical trials. I normally don't blow my own trumpet too much, but when it comes to clinical trials, I'm very proud of what I have done over the last 15 to 20 years, especially in this domain. And all these clinical trials and many meta-analyses, many other collaborative projects has been published in the New England Journal of Medicine. And as you all are either academics or from the industry, well educated, you know that NEJM is one of the leading journals in the field of medical and science, right? So these are all the high impact journals where our team, led by many strong clinicians, very famous clinicians around the world, has published. And I'm also one of the author in all these papers. And in terms of numbers, I may have published more than 200 papers. However, I really enjoy the papers, which are the pivotal papers or the research projects where the patient is always considered, where the outcome is for the patient, and it's the better outcome for the patient from the disease perspective. And as I said, that we all publish papers, we all do a lot of research, but when it can benefit someone, that is very fulfilling. Throughout this journey, these are one of the world's top clinicians or engineers with whom I have worked, and I'm always thankful to all of them. So before I start any of my talk, I always take a few seconds to respect all those my teachers or the friends or my supervisor or colleagues with whom I have worked, enjoyed, and learned quite a lot. Now I'm going straight into my presentation, which is the distributed programming and the MPI. But I would take a few moments before I start working on this discussion. And I would like all of you to focus on these three examples. Weather forecasting, which is like basically solving a puzzle and predicting a large amount of the data. And why I left the three blanks with some dots here, because that's basically the distributed/MPI programming, which divides the data into smaller chunks. Why I have given you the examples before I'm talking, because in this 1 hour or 1.5 hour presentation, I think what we need to understand is that this concept is not that new, or old. Apologies for the my phone. This concept is not a very new one. It has been here from 90s, but the way it has structured itself with the application of this a new infrastructure we have access now, which we call as high power computing, it's amazing. So focus on these three examples, and at the end of my during the last leg of my presentation, I will show you how in the medical, especially in my domain, this concept is really helping us, and how we are creating a solution with the help of such technical concepts, right? So what we are going to talk today, what is this programming, why we use it, what are the key concepts, some of the performance consideration, what are the tools are there, advantages, and some of the challenges, and some of the examples from my team. What are we working on, and how it is helping the patient, and how in the world this MPA/distributed programming is also coming into existence while we are trying to create solutions for our research community and for our, for our business also. And in this pursuit of, in my journey, I have met many people, and I cannot take the name of everyone, but I have a wonderful team, and most of my examples, which I will be providing you, will be coming from the solutions which my team has created. Any questions so far, or I just keep going on? Looks like we are good. Okay. So there are many concepts, in MPI. It's a big book, and there's I cannot cover everything in this presentation. However, these are the few key concepts ranging from process to the topology. There is so many key concepts in between. So I'm sure most of you know about that. I have hardly doing any programming from the last couple of years, because as I'm leading a team of 40-50 people around the world, apart from the research and the collaborative work I'm doing all around the globe, no matter how much I am doing the projects from the technical perspective, but these are the key points I have seen that they always come one way or the other way in our research, right? So I will keep talking about the processes, communicator, rank sizes, how, and some collective communication, synchronization, data types, and a few other bits which you can see on the screen. But always remember that I come from the age when Java was developed, and the event and the signal and the few other concept was there. So nothing has changed from the basics, though. Of course, with the, as I said, with the availability of the high-powered computing, we are getting limitless now. We are getting access to the such a modern way of doing the things that is amazing. As you all see that how this new deep sense has been challenging the ChatGPT or the OpenAI recently. So is these new concepts are coming up with the hardcore programming concepts, and really helping us in our pursuit of creating a new solutions. And then when I will give you the examples from our work in this presentation, I will focus on the two examples. One is how to predict the large vessel occlusion. Now I know that I'm really using big words, but I will take my time and will explain all of you what I'm working on. And the second solution will be the hyperdense signal prediction and segmentation on a non-contrast. And again, I will take you through, and that's what the two examples I will be focusing myself in this presentation. Any question? No questions. I will keep moving then. As I said, MPA is not a new concept. It has been existing in the distributed programming from, since 90s. It's an old concept, but it remains foundational technology in the parallel computing. It's very widely used in the scientific community, simulation, and the hyper. Sorry if some of you don't like when I shorten my words here, but because of the space constraint, I have to speak like this in the high-powered computing applications. Now, while the newer frameworks have emerged, MPI's performance, scalability, and the portability remains relevant. Many new programming platforms, language models, framework has emerged, such as Open, MP, CUDA, Apache Spark, and others. And I have heavily used the CUDA, OpenCL, and Apache Spark in our day-to-day work. And why we are using this MPI? Again, whether you work with the MPI, with the single thread imaging, multi-thread, not the imaging, programming, and few other bits, the key concepts always remain the focus of any application you're trying to create: scalability, portability, performance, flexibility, and many other, verticals which you need to bring in. But one thing I would like to say that these are also the industry standards. If I create a solution, I don't bring the scalability, portability, performance, and flexibility there, that solution means nothing, right? So these are the few of the key factors when you are trying to either teach or research or trying to create a solution from the industry standards. Make sure you focus on all these. And then there are extensive examples ranging from scientific computing to the data analysis. And I gave you 3 examples before I start that, right? The weather one, the medical one, and there was one more. I don't remember on the top of my head. Maybe it's the middle of the night, that's why. How are you doing with the time, Mr. Ajay?
We are in.
We are in time, sir.
Okay, awesome. As I said that, divide and conquer is the, thanks Ajay and Dr. Huja. Let me get back to this. So divide and conquer is the concept in the MPI/distributed programming, as we all know that, right? And I will just take your attention to this particular slide where you have this input image. And I assume that all of you know this, how the medical imaging in 3-dimension or 4-dimension looks like, right? So when you capture the whole brain, you capture, if you can see my face or small miniature picture of me on your screen, you take some slices of the brain, and combining all these slices become the 3D image, right? And let's slow down ourselves, try to focus that when we input the image with the multiple slices here, right? Then you divide this whole data sets into chunks, right? Now, every chunk is processed with a similar code, which means that chunk 1, chunk 2, and chunk n are being termed as a process 1, process 2, because they're working in parallel to each other, right? And then once all these chunks has been processed, you combine all these results, right, to give you a final outcome. That's the crux of the MPI/distributed program. And that's what we are doing every day in our day-to-day work. So with this, as I said, I can go on and on in the MPI domain, but I will slowly take your attention toward some of the work which we are doing in the medical imaging, and then I will bring back the focus into the MPI/distributed programming also. So you know that I have been working in the field of brain imaging from the acute stroke perspective also. One of the issue is, and that's where I'm going to slow down, and I'm more than happy to take some of the questions from you folks, that when a patient comes to the hospital, right, the patient tries to, the doctor or the hospital authorities try to scan the patient from the various modalities. What first we call is the non-contrast brain. Just put the patient in the CT scanner, get a picture of the brain. The next is that you give a contrast to a patient, and then the contrast goes from the lungs to the brain, and then, from the heart to the brain, and then it washes out. And then there are a few other modalities also. What I'm going to discuss with all of you is that a large vessel occlusion. So we have 2 pipes, or the 2 big arteries going in the brain, and two which is washing down from the back of your head. And when the blood goes along with the contrast in the brain, the vessels starts lighting themselves up. It becomes bright. And the job of an engineer or a doctor or a radiologist is, radiologists are the folks who look at the scan and then they try to, report to the neurologist or the rest of the team that how the patient is doing that. This is, and I will show you some pictures very soon also, but that's something which I will discuss this example, and I will show that how MPA/distributed programming, which is our key core concept here, is helping us in our day-to-day work also. But before I go forward, I want all of you to focus on this picture. Once where Arjuna is looking in the water and trying to hit the fish eye. I hope all of you know when. And the other is that when Arjun was a child and he was trying to hit the bird's eye. I won't bring the concept here right now, but at the end of my presentation, I would like you to tell why I showed you this slide and why sometimes less is more in the world of programming, AI, ML / MPI distributed programming. Now, I know that this slide is a very, very populated slide and very busy slide, but that's one of the solution using the distributed programming / MPI / some other concept which we have used in the AI AML domain, where we have the brain, we divide, and one of the process. Now you can see some parallel work going on, right? We start some skull stripping training. We validate. We have created a model there, and from once we have that, we create some 2D and 3D MIPS. It's called the maximum intensity projections in the different directions, because we have a 3D with us, and we have created the MIPS in the multiple directions. And then we do some annotations before we do some training using our model and doing some detection also. Now, as you can see that you are dividing this into various processes. These processes are the slices of the brain, which we call process 1, process 2, process 3, which is a concept in this MPA/distributed imaging. You're using it, you're dividing it, and then you're processing the results, and then you're combining it before you can make a detection. Again, a simple concept from the program perspective. That is, we are working in the AI AML domain, and from there we are collecting all that information and trying to use this technology framework to do our work and create solutions for our clinicians to help the patients. And you will hear these words over and over from me, because our focus is always on our patients and helping our clinicians in the domain where we work in. And God forbid any of us ever have to go in that area. But again, as stroke is a devastating disease, it's not an Australian phenomenon or Indian phenomenon, it's a worldwide phenomena. As the engineers, academicians, researchers, our job is to create a solution so that we can help all of as many as people as possible. Let me just show you a little bit how the first model, let's go back, right? How this skull stripping looks when we are working in this domain, right? Oh, sorry. So let me just slowly take you through, right? As you can see this is the whole brain, which you are seeing. There's a bones, there's a tissue, and this is the vessels which are lit when the contrast is there in the arterial phase, right? And let's have a look at the other example also. Please have a look. And what you're seeing right now on my screen is a solution created by my team, by an engineer called Arpan. And you can see that this is automatic prediction, right? Using the processes, dividing all this, and this is the slices, so that you know what I'm talking. Every time But when it is changing, just slow down here. So we are very, very clear about the concept. As you can see here, these are all the slices, right? As we are moving towards, and the brain, we are going from from bottom to the top, right? You can see that this slice is the top of the head, right? We are cutting it. You can think this as a big potato and you're cutting it into chunks. So these are the chunks which I'm naming it as a slices also. The red area which you are right now looking at, right? That explains what we call this as this area which has been marked by our model, and we are trying to differentiate between the tissue area and the bone area and some empty air area, which is our eyes here, sinuses here, right? And you can see that prediction is pretty nice, not bad. And now you must be asking a question, Mr. Sharma, why you're leaving all these small areas around this? And if you're an image processing person, you know that the beam hardening, the bone, and the few other bits, we want to avoid that. That's why we left few pixels before we move forward on these lines. And the same thing is another good example. As you can see, when you go through the slices, see how cleanly the model has made a prediction. Again, we divide the whole big brain into the slices. And then we combine few of these slices, all of them working parallelly. And when the results come, we combine them together. And that is the crux of MPA/distributed. Look, in this 30 minutes or 1 hour or 1.5 hour of a session, I'm not going to make expert out of you in the MPI. But my job is to deliver you the concept. That the concept is very simple. You take the data, you divide the data, you process the data independently. Still, as you're processing the data, you synchronize, you talk to, to your other processes. You can rank them, as you know that ranking was one of the concepts in the MPA/distributed program. You rank them in a way that whether you want to rank up or rank down. And then from there onwards, you combine all this to make some prediction. Here, the red region which you are seeing is a prediction made by the algorithm after going through all these concepts. Right? So that's the prediction made. And it's a very, very, we started from there, and this was when the model was not doing well. Once when the model become a bit more efficient, you can see how cleanly, as you can see that. You can see the regions here, and this is, you can see the regions here, right? So they started from there, and then once you start having these clean projections or the outcomes, that's how it looks like. All right, let's move to, sorry, not this one. I will explain you this. Some of you may already know that, but some of you may not, and I will explain that, but I'm happy to take few questions if you have any at this juncture. Otherwise, I will keep going. So are we good so far? If yes, then I will keep moving forward. If no, then let me, right? And you can write, is there any message here? Okay, give me a sec, apology. All right.
Is I have published one of the papers, Vandana Sharma, she says, I have published one of the papers on randomization of clinical trials. If you give some guidance for more work in the field, she says.
No problem. I will leave my details and you folks can reach out to me via one of my team members who's here also, Manrit Patra. I'm more than happy to talk later on. Ms. Sharma, Madam Sharma, so that will be great. Okay. All right. Let's get back onto this picture which you're seeing right now here. What you're seeing here is the MIP, maximum intensity projection in one of the direction, which is looking from the top. So again, let's bring the concept of MPI into what we are talking today, right? We divided the data into the chunks. We processes and then we process all these chunks independently, but still talking to each other, which is syncing concept, right? Once we have all the information ready, then we made some prediction. As you can see, a box here called the LVO, large vessel occlusion. I know that when I first started, I was like, oh, what is occlusion? You folks may be more smarter than me, but it's called blockage. As you can see, these two pipe goes up, and when they go in the brain, they go up from our neck, go up, and then they go on the side. And now in this picture, which is called the maximum intensity projection in the axial region or in the direction, you can see the vessels are being created. These are all the vessels of our brain. Look at how beautiful the picture is in all reality, folks. I mean, I don't know whether you are able to see, but you can see that the how complex is the human body. But still, as you can see, all these vessels, the one which is very bright, and here this is the the central one where your brainstem is and all that stuff. And these are your large vessels. This is your ACAs, and these are your MCAs, which is your middle cerebral arteries. And that's how the blood goes in and being supplied to each and every part of your brain through this jargon of network of the nerves, arteries, whatever you want to call that. And once they get occluded, that's a problem. Now you can understand that why stroke is devastating, because as you can see that here, the flow is not going, but on the opposite side, which is the left side. So in brain, left is right, right is left. Don't want to go into that, but just want to make sure that you folks understand this. You can see how beautifully the blood is flowing on this side, but on the other side, the blood was not flowing well, and you can see the area is not well lit, and hence there is some occlusion here, which algorithm has detected. Again, bringing back the concept of MPI over and over again. You have a data, you divide it into chunks. In brain slices, you process all of them independently using the similar process. They have their own memories, right? And from the top, excuse me, I got a tickle. And when you combine all the results, you make some prediction based upon what you're doing. In our case, we are doing a medical imaging, and hence is the results. Now, some of you may know that, some people may call them, hey, Mr. Sharma, I have used this SLURM, SLURM, SLURM. That is at the level of hardware itself, right? Where SLURM helps you to divide your work in such a way that you can use it can control the processes from the hardware perspective or from the server level perspective, whereas MPA site distribution is at the application level. So what I'm doing, there's a key difference between that. So always remember that. Sorry. This is another picture, another example of the work which is done by my team. Again, imagine, it's very easy when you know what you're looking at, especially when you're looking at this image. There's a bilateral, both sides. Bilateral means both sides. Occlusion means blockage, right? On both the sides, as you can see that. These are the difficult examples which work very well in our algorithm. And remember that in the peripheral hospitals or in the middle of the night, when there is no doctor or the junior doctor available in the hospital, if such cases comes in and the algorithm tells you, the doctors can quickly take a decision whether they have to go for the thrombectomy, which we call that, put a wire in the body and then take the clot out, or to give the medicine, or to have a combined bridge therapy to help the patients. Again, as I said, that we are very, very passionate about what we are trying to create here to help the doctors to take a decision for the patients for the better outcome. That's always our focus, always. Now let me move into another example, and I am sorry if you get bored with these examples, but my example will always come from the stroke perspective. And as I said, that I work in this domain very passionately. And the next thing which I want to talk to you is a very dear, very, very close to my heart. So as you are seeing this picture, this is the skull, this is the brain, a part of the brain, and the red color, which I will explain you. But before I go forward, I want to just show you back again. This picture which you get is the vessels which are somewhere hidden here, unlit, because there is no contrast in this brain. So this is called a non-contrast picture, whereas this is the contrast. It's called the computed, it's called CT angio. So it's when we give a contrast to a patient, that's how the vessels are lit. And if any part is not lit well, that's where we call this as occlusion blockage. And that's where we create a solution using this concept which we are talking to show where it is occluded. All right, let's get back to this non-contrast picture. Now your question can be, hey, Mr. Sharma, why you're going from the non-contrast, contrast-based imaging to non-contrast? Folks, we live in a world where the wealth is distributed not evenly, right? And in emerging economies like India, where the 1.6 million prevalence of stroke, the thrombectomies and the other medicines, right, are available, but it's still not being given to all of them who are suffering from the disease for the many reasons. One is the lack of awareness. What heart attack is to the heart, stroke is to the brain. I know that India is far, far ahead when it comes to the, cardiovascular medical aid. It's even available in the tier 3 and tier 4 hospitals, or people are aware of it. But when it comes to stroke, and I want to take a few moments here to, generate the awareness, or at least emphasize on it that, stroke is a disease where there is still not a lot of awareness in the community. I don't want to comment on any other area here, including our situation back home in India from the medical milieu perspective. So why I always focus on the modalities such as non-contrast, because it's cheap, it's worldwide available. It's not that, oh, in Australia we do like this and in India we work like, in some other way. Non-contrast is a standard phenomena across the world: Africa, India, Bangladesh, Pakistan, anywhere, including Australia and all these so-called well-developed economies. This is the standard way of scanning the patient. And now you can appreciate that how the computer science, all these concepts of MPA/distributed programming are helping us to create some solutions, which is actually more powerful for the patients, families who are suffering from it, and how as an engineer, clinician, researchers, we can all come together to create a solution which helps them, right? And that's the fun of solving the problems, fun of helping each other, so that we move toward the better world, or align ourselves with the mother nature, whose only job is to produce better and better every day, right? So let's get back to the non-contrast here. So this is a non-contrast imaging. Whenever the tissue changes, if we can pick those changes as early as possible, right? Which means that we still have a time to help the patient. The longer it will take to help the patient, that is more problematic, because all these ischemic changes, all these changes in this area, which we call tissue, all these small gray areas is tissue. There's some CSF. Look, I don't want to teach you the medical or anatomical structures here, but all you need to focus when I'm talking about the MPA/distributed/AI/ML domain, you need to understand that this is the area where we are targeting in this particular solution we are trying to create. So the red region which you're seeing is representing of the hypo, which means the loss of signal. So as it says that in case of the acute ischemic stroke, the early signs of the brain infarction is when there is no oxygen to the tissue. Now, how I can tell you and how you can visualize that here. Can you say the nice sulci, this gray matter, white matter segmentation here where my pointer is moving? Can you see the pointer here when I'm moving my mouse, or you can't?
Yes, sir.
Okay, wonderful. Thank you. Okay, let me bring my point. So as you can see, this is nice differentiation of a gray white matter here, right? And also this is called the gyrus and the sulci area. You can see that differentiation is gone on the opposite side. It's all intermade. What I normally use the French word mélanger, right? It's all mixed up, right? And this is a well-established changes. What our job is as a stroke researcher is to pick this area as early as possible. It's sometimes some of you call this as a golden period, which is in the myocardial infarction also. So when I was trying to, and then I will bring the concept of MPI into this also. When I was trying to create a solution, this solution is not mine, what you're seeing on screen. That was one of my mentor, Dr. Christensen, who was originally from Stanford, now works in Denmark. And this was his, I think it was 2019, 2018. We were at the Los Angeles, where I'm going day after tomorrow for the conference called the International Stroke Conference, and I'm going again for that conference. He said that, Gagan, why don't we just work in the simplest way, wherever possible, to create these solutions, right? Right. And I said, okay, yeah, no problem. So his idea was that just take a non-contrast, do some tilt correction, remove the skull, remove all these, beam hardening, CSF, which is somewhere here, right? And then some non-linear, and then mirror it up, divide it up, and then try to create some heat map, and that will tell you that there is some occlusion, as you can see here, right? There's some differentiation on this side, but there's none on this. Okay. So that was his solution. Now, again, you can understand that all these things can work in parallel. You divide this into the chunks. You can divide the data into the chunks. You can process them independently. Then once you have processed it, you can rank them, which areas you want to drop it, which areas you want to pick it up. And then you can synchronize between the processes. When you synchronize between those processes, the final results of managing all these parallel processes of the, in such a system, you can get the results like this. Again, programming concept, you're bringing it in to create solutions for your clinicians and for the rest of you, or you want to focus for the audience which you're working for. In our case, it's always the patients and the doctors. Now we try to get this solution, but this looks very nice on the picture which you're looking at right now, but it's sometimes not always very optimized, and the sensitivity and the specificity of that may not be that correct. So the engineers in my team starts thinking about that, Gagan, how we should be doing it. Should I use some midline detection stuff, or should we do the brain extraction and play with this? Again, focus on this. Nice differentiation here, but no differentiation on this side, right? That means the tissue stuff has been affected badly. Or he said that, should we do the mirror generation, then do a smoothing by bringing the, what was this? This one, midline detection stuff, right? Before creating some intensity maps. And I said, look, let's see how it works. So that's where we came to, we zeroed down on an algorithm which some of you may name as AI/AML hyperdensity detection methodology, right? What you're seeing on the screen is a schematic representation of the various steps which are either going independently to many other processes in parallel, and again bringing the concept of MPI/distribution. Remember this. You have to divide and conquer. This is all these distribution systems concept in programming and doing, and we are applying that in our algorithm generation also, right? So you have a brain, which is your input image, and brain is made of many such input images, right? You do some pre-processing, then you pre-process image, and in parallel you can do the mirror. So you have a picture and then you have a mirror of it, and you do some maths on it, and you send it to, now this is where you divide or create the two independent processes. Then you give this to a network which we call the segmentation network. Now here the sync happens, right? If this process works independently and doesn't work with this other process, they have their own memory pool. Again, I can go very deep into the programming concept, but that will be a little boring. That's why I want to bring some examples here, which makes some more sense of the parallelization of your work and creating some solutions, which makes a final prediction where the red color tells you, oh, that is the big infarction. That's where the lot of lesion, what other word I can use to make it easy for you folks? Anyway, lesion is the easiest one I can think of on the top of my brain. Anyway, right? So that's how this solution looks like. So when you're looking at that, these are the two images while you're looking at that. I hope it's not stretched. The one way which is on the left-hand side of my screen is the ground truth drawn by the neurologist, right? And on the right is the prediction made by the algorithm. Now pause yourself here for a few minutes, or maybe a few seconds or minutes, and focus that how useful is that in the clinical settings domain. To draw this on many slices, the doctor has to first scan the patient, then use this modern system of all the scanners. They can do a lot of work also automatically. However, they may not be validated enough so that doctors may or may not use that. And resource allocation is always a problem, not in our computer science and high-powered computing, but also in the hospital where there is a busy line of patients. I can understand from the concept perspective of Australia and some other countries where sometimes we have a free time on the scanners, but I have seen many hospitals, including PGI, AIMS, NIMHANS, all around India, where there's a patients after patients. Yes, it's sad to see, but all these patients and their data is also very useful to create a solution for the next generation. So in India, we are sitting on a gold mine when it comes to data because we have the numbers with us. We have the controls, we have the patients also. But here you can understand that when a patient is being scanned, and all your programming concept which we are talking today, right? They come handy to you. You create something meaningful where the doctor look and say, that's the region I should be focusing on. Wow. Okay, well, I have got the answer from this minimum sufficient imaging, and I'm going to help the patient one way or the other. That's the solution which we are trying to create. That's where our team wants to focus on so that, we can help the patients. Always remember that all these fancy concepts, the difficult concepts which we are reading in the books, when it comes handy in our day-to-day life, where we are really trying to use these concepts to create some solutions, to help someone. Again, these words, help someone, helping the clinicians, better decision-making, but the final end goal is always, that is patient. And patient means anyone who needs our help in this stroke domain, using all these fancy and modern bit of difficult concepts, which sometimes seems difficult. It's not difficult if you enjoy them, right? And apply them to create a solutions that's so fulfilling and amazing, in our day-to-day life. That brings me to the end of my presentation. And look, we have talked about the many concepts here, right? We are talking about, I have talked about, what do you call this? From the technical perspective, and I've given you two big examples when it comes to our two algorithms which my team is developing. But then you must be thinking, what is MPA/distributed programming? I always think this as a team leader, which divides, which is processes, assign the work, which is different independent processes using the same shared, what we call this, shared memory pool, or has their own resources. Then it assigns the task, which is like you're processing the data, and then efficiently combining them, which is you're syncing to produce the final results, to solve the problem. We are trying to do the problem solving here, which is using all these, lesion determination by classifying and segmenting it. And here in this concept, we are trying to, the answer is that, hey, tell me where is the occlusion in these vessels are. So in our case, we are using these two examples. The other examples which I gave you, which was here. your weather forecasting, because that also needs a lot of data which needs to be combined. The other good example, if you are into movies, animation, is rendering, joining these clips to create or trick the brain when audience is watching your movies. So all this MPH/distributed programming systems ensures that all pieces come together seamlessly so that the experience at the end is very, very nice, soothing also. Questions? Should I stop for a while and we can? All right, here we are. So that's by and large, I want to talk to all of you, and thanks for the attention. I know it's a bit late for all of you, and I don't know how in the world we are having so many people still focusing on what I'm speaking. So I'm happy to have some questioning from all of you so that we can close this session if needed. Back to you, to the moderator. And I can see some hand is being raised by Bhagiraj Yadav. Is there any questions for me? Okay. Am I audible or I'm just speaking to myself?
Yeah, you are audible, sir. Bhagiraj, you want to ask any question?
Maybe
You
that
can
was false alarm.
write your questions on the chat also. Or anyone from the audience wants to have any questions?
Ajay sir, you had a few questions for the audience. Would you like to take it up?
Not asking questions, I have to ask questions to them. So
Yeah.
I'm asking a small question, pool of questions, maybe 1 or 2 questions to them, if I'm allowed.
Go for it. There's one question. I can see that it's coming in writing from them. It's a very good question, Doctor. Give me a sec. Look, I think I need to get my number changed. Dr. Prashant.
Yeah.
Wonderful question, and honestly, I was expecting that, and the answer is no in my case. But in my competitors and some other people, yes, GPU is required. But for training, yes, definitely you need a GPU, right? But for the implementation, as I said, my focus is always on using at least to create a system which are not resource intensive. And you can appreciate from the mindset and the focus which our team brings into it, that we don't want to create a solutions which need a fancy hardware. If we can develop something on the GPU, yes, it's going to cost us, but at the end of the day, we are the researcher. We have a research-based company where my engineers, sometimes my students are working. They can create a solution that needs some resources. But after that, when it goes on the ground, if it is possible to run it on the CPU. And why I like your question, because that's a hot topic in our team also. We are trying to develop the algorithm which was behaving quite well, but we need to increase the depth of the layers in this artificial intelligence / the machine learning stuff. And my focus was that, hey, just don't increase the depth of the algorithm and make it very resource intensive, because at the end of the day, on the ground, when our team is working with the doctors, we have to make sure that we deliver within 2 to 3 minutes. If it's taking 20 minutes to deliver the data, by that time, patient will be in a different situation, doctor will be in a different mindset. So fast is not always the furious, especially in this acute stroke. So we prefer to make sure that the solutions can run both on GPU and the CPU, but at least on the bare minimum, which is CPU. I hope I have answered your question in great detail.
Yes, sir. Thank
you. On the chat, please start answering this question so that I can ask one more. and I want to see how are you answering.
Hello.
Hello. Yeah, good going. 20 people have answered. Let us see how you're answering.
And there is a question in the chat box once again.
Yeah. This is question number 3 for today. I just want to say that answer the questions promptly. The first to answer and the correct answer, the second to answer and the correct answer, the third to answer and the correct answer are going to get reward points, which we are going to accumulate at the end, and you are going to get surprise, which is going to reach your homes. Up till now, 96% of people answered it correctly. Please answer fast. I'm going to give you 30 seconds more. So grab your chance, grab your points. We are going to give reward points to the people who becomes reporters in our sessions, like what Navjot ma'am did today. I wish there should be volunteers for that. If you are a volunteer, write on chat for tomorrow, the first session and second session. So far, so good. 38 responses up till now, and 37 are okay with it. Great. One more question. Let's have one more, then we can go. One more is there. Please answer the questions as fast as you can. And share your webcams. Let's have a photograph with Mr. Gagan. मौका नहीं मिलेगा ऐसा. I'm sharing mine. Let's share our webcams. We can see people coming up. Let's have some more people. Yeah. Jiten ji, how are you? Jiten ji, you're mute. Sunil Rathod. Hi, sir. Please share your webcams. Dr. Mohit. Dr. Mohit, कैसे हैं sir? How are you? Please don't. अभी आपकी फोटो खींची जानी है. We have to click photographs, यार. Give us some time. There are many, so I will request Neha to take care of this activity. Srinivas sir is traveling, so, and Manoj Kishore sir, if you can. Oh,
As per your instructions, I am in the full photo mode, sir. Smiling.
you make people smile, so you have the right to smile.
And I'll take this opportunity to say, Gagan sir, thank you very much.
No problem. Pleasure.
It's always a pleasure to meet you and to interact with you. The kind of work you are doing, beneficial to the entire world, I should say. Whenever I listen and see your work, I'm inspired that this is the way passion and profession are meeting each other. So thank you very much for all the work you are doing and the way it's inspiring our teams at Lovely Professional University. And today, all across India, we have faculty members from various universities all across India. Thank you very much, sir.
Pleasure is mine. Thank you. All good. Have a great rest of your night.
Good night, sir.
Thank you, Gagan sir. We will
right.
see you once again on the last day. In the meantime, I want to say the participants, please promote yourself. We are making some social media posts and punching it on our social media platforms. We are getting the links on platform. So not only like it, plus comment on it. Comment how your session has gone, how all the sessions are going, right? And promote yourself. Yes, Sunarama?
Sir, there is a request from Vandana ma'am in the chat. Gagan sir, I'll request you to just go through the request from Vandana madam in the chat. She's looking for a research collab. Yeah.
No problem. We can talk offline on those, right? Not now, but we can talk later. So thank you, everyone. I have to go. It's almost like 2:30 a.m. here, so I apologize. Bye.
Bye-bye, sir.
Once again, thanks a lot, sir.
Thank you.
It means a lot
Thank
to
you.
us.
Thank you,
No
sir.
problem.
Thank you so
Pleasure
much.
is mine, and thanks for the opportunity. And thanks everyone for staying so late. And I know that you have all other responsibilities also, so I appreciate your time. Cheers. Bye.
Thanks,
Thank
sir.
you very much, sir.
Thank you,
Thanks
sir.
a lot.
Good night.
Okay. Thank you, sir.
Vandana ma'am, yeah. So I'm sharing my contact in the group, Vandana ma'am, and I will be connecting you to Gagan sir, so we can discuss this personally. So I'm putting my email in the group. Ma'am, I request you to write to me so that I can share the contact also. Otherwise, I'm there in the WhatsApp group. From there also we can connect. Okay, I'm sharing. Ma'am, please check your message in the group. Thank you.
Thank you, everyone. We would like to see you tomorrow. Nobody answered my question. Who is going to become the reporter for the 2 sessions? You are going to get reward points. Okay, I'll ask you on phone. Don't worry. Thank you very much. Have a great time.
Thank you very much, Ajay sir. Thank you very much,
Thanks a lot,
Manpreet
ma'am.
madam. Thank you.
Our host Neha is there. You can end the session, Neha.